All right. So first and foremost, it's a great pleasure to be here and very honored. So really appreciate you all allowing me to present all this to you. Um, two things to first start off. In the next slide, I'll have my email. So if you send me an email with your thoughts and ideas about the platform, I'll go ahead and send you some swag, some Certus Core swag, just to incentivize engagement. Also, for fans of steganography, if you can find some additional meaning in our IBIS logo there, I can give you a little bonus prize. So, and I'll get the address for your department from John to send folks who send me an email some swag. So, those are my two uh, carrot and stick type things to keep engagement going here. So, all right. So today we're going to go over the origins of SKG, keeping a focus on the intent of this class, which is intelligence analysis and stuff like that. So, and trying to focus on where Jake, Tim, and myself came from in terms of intelligence analysis, that culture inside the DoD and IC, and how that got us to where we are now with the platform itself, and how we build tools to facilitate intelligence analysis more broadly. So, origins of the platform itself. So we kind of go over like what the prototype stage was before we actually started the company and started building out SKG proper. We'll go into what SKG is currently, and kind of where it's going to. And then we'll go into a demo of the platform itself so we can see kind of like how we went into applying ontology engineering and ontology practices to the intelligence analysis workflows that we've trying to instantiate inside the platform, and ultimately kind of how we see that moving forward. So presenter, my name is Joe Blankenship. I'm the Chief Data Officer here at Certus Core. I have a very broad background. I started off as an electronic engineer with a focus on digital signals processing. I served 7 years in the Army where I did signals intelligence. Once I was done with that, I got into data fusion analytics and then eventually data science with a focus on geospatial data. And eventually got into the more broader data science, data engineering practices. And that eventually led me to ontology engineering and knowledge governance and those practices, which is what I do now here at Certus Core. So, and email is joe@certuscore.com. So, like I said, feel free to send me your thoughts and happy to send you some swag as a result. So, going into how we got here in 2024 from way back in 2019, even before then. I came into the picture in 2019. So I was on my way to St. Louis to work for Monsanto Bayer. At the time, they'd had a merger and they were trying to consolidate their geospatial data holdings. And I was like, ooh, that's a good challenge. That's a ton of data. It's a lot of agricultural stuff as well, which had piqued my interest at the time because I was an economic geographer and I was studying at University of Kentucky. So I was en route to go and do that. And then Jake Dial, one of my co-founders, very savvy computer scientist and project lead, he was like, hey, I've got this project and it's knowledge graphs and it's building stuff down here that's fusing tons of heterogeneous data. And I was like, oh, this is awesome. So I told Monsanto very nicely, like, hey, I have a better offer. And then I moved myself down to Florida again for like the 4th time. But given the choice between St. Louis winters and Florida winters, I think I made the right choice. So when I got down there, they threw me down in the basement, and that's when I met Tim Toohill, my other co-founder, a brilliant software engineer, and we started working on this project. And essentially, it is just that, tons of heterogeneous data, very complex, very big, billions of records, and having to fuse this all into one data endpoint where people could interact with it, ask questions of it. And the task was to build a knowledge graph of all this stuff. And it was to take all that raw data and to automate as much of that workflow as possible into an endpoint that non-technical leaders and decision makers could interact with and use to make quick, efficient, reliable decisions, event-driven decision making, in other words. So the way we went about that is Tim rapidly prototyped what was the foundation for what is now SKG, a very savvy, very involved user interface that had a lot of tools, a lot of effective user stuff for doing intelligence analysis, and our analysts could actually get in there and ask questions. but there were a lot of challenges with that. People were able to use it, were able to get a lot of value out of it, but they had to learn a query language. They had to learn about the complexities of loading data into this architecture, which was mostly cloud-based. And there was a lot of complexity that went into this original prototype. So once we had a system that could enable some parts of, we went from raw data to decision making, we had to resolve another issue, which was the intelligence analyst could individually interact with this platform, but there was no real easy way to help them foment common understanding between what they did with one iteration of the knowledge graph and the next iteration. So that got Tim and I thinking about, well, how do we focus on consistency and rigor and reproducibility of knowledge graphs over time, to where if we have John Smith drove a car, that representation in terms of both being abstract, like a person drives a car and John Smith drove a Ford, would be consistently represented and reproduced each time inside the graph. And we could resolve backwards and have backwards compatibility between graphs. So that got us looking into a lot of governance layers on how to do that. And we came across ontologies and we're like, all right, well, how are we going to implement ontologies in addition to all the common data engineering stuff like schema, data dictionaries, metadata, data catalogs, etc. So we started with great ontologies like DBpedia, Yago, Sumo, Yamato. There's a bunch of different approaches to it. But at the end of the day, those things were kind of like a batteries included ontology, but not every customer needs a batteries included ontology. They don't need the entirety of Wikipedia in their knowledge graph. They just need the knowledge that they need to do their jobs effectively and then augment as needed. And great ontologies were not a good way to go about that initially. A lot of pluses with that though. DBpedia does come in RDF. There are a lot of like easy peasy get started type stuff that you can do with great ontologies. But then for the research, we were trying to find people inside the DoD and IC that were using ontologies for stuff that was more rule based and not as and less alignment based. So we came across a publication from the U.S. Air Force where they were using ontologies to represent their fighter jet systems, all the systems and subsystems, how they relate to each other. And as a result, we looked into how they were doing that, and they were using BFO for that. And I was like, well, what is BFO? I've never heard of this. So had to start digging heavily into BFO and top level ontologies, and found Barry Smith's book. And we're like, this is great. This is like exactly what we're looking for. It allows people to approach what they do as a subject matter expert, apply rules, and align what they know to a more abstract layer, and then use that abstraction to better communicate their concepts and ideas to other places that are not familiar with those domains of knowledge or communities of practice. So it made the collaboration and the coordination stuff there. It helped enable common understanding at a much more base level, and in a way that anybody that wasn't even trained in ontologies or knowledge graphs like that could easily grasp. Like everybody understands a person, and if you give them the diagram for what a person is, they can either agree or disagree or work with the concept of a person. So at that point, we had good data to decision-making stuff. We had now a way to implement common understanding. But just because we can reproduce a knowledge graph now consistently, rigorously, does not mean that how we use the knowledge graph can be done consistently and rigorously. So we had to go back to the basics of, well, what kind of data are we putting into the knowledge graph at the beginning to then get that knowledge graph at the end that is usable by decision makers, so they can actually get down into the weeds of what's inside the knowledge graph. So, and as you know, in intelligence analysis, it's garbage in, garbage out. If you have bad data or you've prepped your data poorly, then you're going to get bad results at the end. No matter how good your modeling pipelines are, no matter how good the platform is that you're using, the data is going to determine the outcome. And if you have bad data, you're going to have a really bad time trying to figure out things at the end state. So we had to go back to the basics of like, well, how do we do data governance and data management for this type of knowledge graph and governance approach? So we ended up writing a like mini manifesto ebook called Sushi that went into essentially how to do modular data operations. Go from data management and data governance to encapsulate data assets and metadata, to then use that information to do cradle to grave lifecycle management for your data assets in a way that helps facilitate consistent, rigorous production of knowledge graph artifacts. So we had to kind of reinvent the wheel in a lot of ways to kind of marry up ontology engineering, data engineering, knowledge governance, and then data governance in a way that was complementary and facilitated a more constructive approach to doing data operations writ large for knowledge graph production. However, even after we have that, and now we can now produce knowledge graphs a bit more consistently, given a lot of work on the ontology engineering side, there's still the question of like, well, what tools do we use to implement this? Because in intelligence analysis, in the DoD and IC, in government writ large, there are systems that have internet access and systems that don't have internet access. There's systems that talk to each other and systems that don't talk to each other at all. So we had to like really address like, well, we have the models, we have the approaches and methodologies, but what kind of tools do we use to facilitate these kind of practices in a way that are also consistent and rigorous and help enable consistent workflows so that one data engineering team can talk to another data engineering team, they understand exactly what kind of governance is going on there, what kind of ontologies are used, what kind of data is used, and ultimately how that's affecting the knowledge graph production. So we looked at a lot of different stuff, and eventually, once again, Tim being the brilliant mind that he is, he was very keen on implementing fairly good architectural solutions and engineering solutions for those kind of tooling practices, which we'll get into when we start talking about the platform itself and go into the demo. But some of the key standards there that we were looking at were, we didn't want to have vendor lock-in. We want to have easy on-ramp and off-ramp of data practices, governance practices, metadata, data, graphs, you name it. We want to make sure that if you as a subject matter expert or you as a data engineer have tools that you know work as good and you're not confident in having done inside the platform, we didn't want to lock you into that. We want to make sure that in terms of workflow, you're maintaining a workflow without being constrained by the tooling that someone gives you. Because we just being, Jake, Tim, and myself, having worked in government for decades at this point, we have seen a ton of vendors who will give you software. And once you're in that software, you're just in that software. That's it. It's like, and that is good in a lot of ways because everybody has consistent practices, but it's also constraining because if there's something can be done better and you find something new that has to be done to facilitate your job, often those platforms will not allow you to add that feature or allow you to manipulate that feature to enable a new workflow. So we wanted to allow people to use open data formats, open data standards to enable on-ramping and off-ramping for the platform to make it a more complementary process in terms of intelligence analysis, ontology engineering, data engineering, you name it. So I think for the most part, we've kind of answered a lot of the tooling questions around how to enable this, because there is a gap in a lot of ways still between the more theoretical aspects of ontology engineering, data engineering, stuff like that, and the practicality of tools used to facilitate those practices in the real world for any number of spaces. So our platform as it stands right now is highly modular, allows a lot of flexibility, allows people to do exactly what they need to do to build the tools they need to build the data artifacts they need to build, and to enable the decision makers and leaders with the things that they need to do their jobs better and faster. And that was kind of our goal when we first started this thing way back in 2019. And I think Jake and Tim even before then, before I showed up. So that kind of leads us into what SKG is now today. And in my own words, it's essentially a knowledge governance platform. It allows you to encapsulate data engineering, data science, data analytics, data governance, knowledge governance, and rolls it all into a platform that has a keen focus on workflows and workflow management for all those things, because it's a lot of stuff to do for just one person or a small team of people. So you need to make sure that the platform facilitates a high level of consistent expression of what's been going on, and then collaboration and coordination between the elements doing that kind of work to facilitate the production of knowledge graphs, ontologies that have consistency and rigor in their production and moderation and management. So we wanted to make sure that, with that on-ramping and on-ramping, we democratize the data access process as much as possible. And with the caveat of saying that the platform itself has a lot of security layers on there to make sure that, in the most ideal environment, you have the open source internet and you're doing that stuff like that, and everything that you're using is free and available data, and there's no security issues whatsoever there. But in intelligence analysis, you have to worry about classification levels, you have to worry about systems in which those classified artifacts exist and persist, and that there are ways to air gap between those systems and exchange between those systems. And you also have to account for those kinds of data exchanges and those kinds of import exports as well, because there will be migrations from your platform to other things. And when we built the platform, we had a keen focus on making sure that that was as simple a process as possible. So you could deploy this thing anywhere. You could take your workflows from academia, bring it right into your next job, go from your next job to your startup. It didn't matter what you're working with this stuff. You could do ontology engineering the same way each time. And the way that we kind of enable that democratization in workflows is by a focus on enrichment of metadata and data practices. In addition to Sushi, we make sure that we are looking to enable people to build ontologies just the way they do them in any other ontology tool, build data artifacts the way they build them inside of any other data tool, build analytic products the same way they would do it in any other analytic product or analytic tool. So, and the way we do that is by having consistent metadata expressions in there. So the stuff you do with BFO would be expressed the same way, encapsulated in the metadata that goes along with the data assets that are being modeled with those ontology practices, and then result in a knowledge graph. So, and it's what's great about that is it really enables cross-organizational decision making. Like if you have an engineer that understands the platform, understands the concepts that go into the platform, that's much easy to transfer the knowledge of underwater unmanned systems or airplanes or transportation or operational security across things, cybersecurity, you name it. And like I said, I would say the platform, we are looking at a lot of ways to help overall increase the coordination and collaboration in that way to essentially, like I said, trying to answer those problems and solutions that we had when we first started this whole process in the first place, which was enablement of good governance, good coordination, good expressions and common understanding, and also to enable people to use the tools they already know how to use. Like if you use Excel, use Power BI, as a data scientist and a data engineer, one of the hardest things for people to admit is the fact that Excel is the predominant data analytics and data science tool out there. Like it's the most ubiquitous tool out there. People use it for everything. If you're using LibreOffice, you're still using the spreadsheets in that. So at the end of the day, people are gonna be looking at flat tables and stuff like that. So it's one of those things where if people are using Excel, they're using Power BI, they're using Tableau, they're using Protege, they're using whatever they're using for any aspect of the workflow for this knowledge governance, that we're able to facilitate import and export from those tools, and then make sure that if we can do as much stuff in the platform as possible, that that's being facilitated to the user.
Joe, I have a question.
Yeah, what's up?
So this sounds, I haven't seen it yet, but I was on a project at NGA long time ago, 10 plus years ago. And at first we were like, oh, ontologies are great. We're going to use all of them, right? Brought in 540 ontologies, and we're like, yeah, we have BFO, we have Dolce, we have Sumo. We just brought in everything. Did you guys do that at first and then realize, oh, we need to have some type of semblance here with a top level and maybe a mid level? Or was it that you heard through the grapevine that, hey, DNI is about to mandate that they use BFO and CCO? Or did you come to BFO and CCO organically?
It was the latter. We came to it organically. So we started out with Yago at first, and we're like, oh, this is great. It's a Wikipedia extraction. But then we realized, like, think about top level, mid level, and then application ontologies. It's like Wikipedia just is a smush together. It's like I think Yago uses the info box aspect of Wikipedia to do a max out extractions of the ontology itself. And what that does is it gives you a lot of those mid-level ontology concepts like a person, place, thing, but it also gives you the instantiations as well and connects them to those things. So it's like it's a massive hairball, and it's highly unmanageable. And to augment that over time is extremely tedious and complex, and there's no way to regulate how person A and person B would add to that great ontology over time. So in terms of overall knowledge governance, we needed something that was more top level down. To enforce good practices of expression and common understanding from a baseline of abstract ideas downwards into mid-level ontologies where everybody can agree or disagree on these things. But at least when they're disagreeing on consistent expressions of the thing they're trying to argue about.
Yeah.
So that's where BFO was like the no-brainer choice for us, because it allows people to build their own knowledge upwards. So by having that top level down governance. So something like CCO is a great example of that, where it's this good mid-level expression using abstract top-level things that are consistently regulating those mid-level things, but can be leveraged to instantiate a bunch of data into those common expressions at the mid-level. So to us, that was a much more tenable approach, because at the end of the day, we have to hand this off to a user, and the
Yeah.
user has to manage this by themselves eventually.
Yeah.
So you want to give them as much tooling and knowledge about how to do knowledge governance, data management as possible, to understand the implications of every time you enrich your metadata with those processing steps, that they're being governed in terms of, schema, data dictionaries, et cetera, through BFO, and not something that is constantly shifting at the top level. So like
Yeah.
great ontologies, the implication there with DBpedia is that if you reprocess or integrate Wikipedia stuff might change inside Wikipedia, because it's open edit.
Yeah.
So BFO is rule based and it's
Yeah.
abstract, it's high level. So, and that's not going to change canonically at all,
No.
ideally.
And even if we change things, we know that it goes through a review process, and they're going to come out with change logs and everything. Now, one more question.
Mhm.
Do you find that you get frustrated because of the lack of object properties, or do you try to wholly use the object properties that are in, say, BFO 2020 and the new version of CCO, or are you having to create a lot of new object properties in order to do your work?
So we try to stick to BFO. Well, so when I say BFO 2020 and CCO, we try to stay more aligned to the ISO 21838-2. So I try to refer up to ISO, because that's like a lot of people like, it resonates with ISO because they understand ISO, especially the quality control stuff. But yes, we try to adhere to BFO CCO as much as possible, because it is the most established and probably best defended approach to doing that process. And we only augment as needed, but we augment at the mid-level or the application layer as much as possible, and then try to record that upwards, because we understand that each organization is going to have their own expressions, but we don't want them to creep outside of what BFO is established as being legitimate or being efficacious long-term strategically.
Yeah.
So, and I think how CCO has worked with BFO is a good example of how to do that. So we try to adhere to those models as much as possible, because if someone's going to augment around that, it's good to have those two there as a baseline for how they would go about doing that. So, but yeah, there are constraints and stuff like that with the object properties. And like I said, when we do the demo here, we can go into how we kind of we have a baseline of stuff we have in there, but you can obviously augment. But once it's in your platform, that becomes part of the metadata structure for your ontologies and your graphs. So it becomes part of that canonical record inside of your platform that you can export, share, and stuff like that. So we
Because you
try
really
to
have to
maintain
have you really have to have a mind on the future and a mind on integration and data centricity. Like 10 years ago, we were the only game in town, so we could do whatever we wanted, and we didn't have to worry about, oh, somebody else is going to come in. And if they wanted to come in, we brought them into our platform. It wasn't like you're connecting platforms. So yeah, that's really good. Okay, thanks so much.
No, and like I said, it's when going back to the origins of this thing. It's like, going from, we have to go from data to knowledge graph, and then knowledge graph back to data governance. And provenance and lineage, like I think most people that talk about data operations, they talk about provenance and lineage quite a bit, and it's because it's critical. Like if you don't have metadata to represent that lineage from, I acquired data and now I'm using data in my organization as part of my data lifecycle management process, there's no way that once you abstract that and use that in a knowledge graph, that those things are going to transfer. You just have these kind of like ghost IT emergences of like, I have data and then just magically appeared in my graph. Like there should be some backwards lineage between, if something's wrong in my graph, I need to know where it went wrong in my data. And if something's problematic in my data, I need to know how it's going to affect the next version of the knowledge graph. So there has to be that reciprocity between endpoint and your ETL and acquisition for your data lifecycle management. And like I said, BFO and CCO kind of help you also think about that, because it becomes a bottleneck in the workflow for producing knowledge graphs if you're using it correctly. And that's the way that we kind of use it with our thing. Is like, I guess you can go to the demo and we kind of go through our archetypical workflow for this stuff, and kind of probably answers more of these questions here. Let me stop sharing, stop presenting. Now I need to share my screen here. So let's see. I think that's it. But everybody can see that. Can everybody see my dashboard here? All right, sweet. So this is, oh wait, where'd y'all go? Y'all disappeared from my main window here. There we go. Oh, that's so I'm using the Teams app for the first time. I usually use Teams through my browser, but since I was using my browser for the demo today, I was like, oh, I can't see. But Teams does a lot of cool stuff. It actually popped you all out into a separate window that I had to track down and find in my my desktop here. All right. All right. If everybody can see me and hear me still, then I shall proceed with the demo here. So, all right, sweet. So, SKG. The focus here is to work with subject matter experts, ontology engineers, data engineers, and the non-technical or technical leadership who are going to be using the outputs of this system. So those are like 4 of our main personas for this platform. Now, the data engineer comes in a little bit later, but the folks we really wanted to help with this through data engineering practices were the subject matter experts who may or may not have technical skills, and the ontology engineers who have been schooled and trained in ontology engineering tools, techniques, practices, stuff like that. So who may or may not have any kind of data engineering background or may have some computer science background, but no insights into our platform itself. We want to make that onboarding and that learning curve as flat as possible. So as you'll see here, we have the ontologies kind of building area down here, and then we have the knowledge graph productions that are derived from these ontologies up at the top here. Now, the platform itself has a lot of tooling as well, but we'll just get into a case study here. So when we first started the company back in 2021, 2022, one of our first projects was building an IoT laboratory and then taking that IoT data and putting it into essentially data dashboards and a data representation model knowledge graph for the systems and what's going on inside the operational environment. And at the time, it was really just a sensor environment. But eventually the implication and what we're currently working with another customer on is unmanned systems, unmanned underwater systems, to be more specific. So in the course of trying to figure out how we're going to pipe, millions and billions of MQTT IoT records into a platform and represent that inside a knowledge graph, well, we kind of need to build some entity models around what the scope of the operational space for the unmanned vehicles was, and ultimately how we're going to represent that in the knowledge graph. So the place we kind of start with our workflow is with building out a concept model, a conceptual model that both the data engineer and the ontology engineer can work with to both produce consistent BFO compliant ontologies and build the ETL pipelines used to facilitate using those ontologies to produce knowledge graphs. So there's a few ways we can do ontology work at first. So like we said, we try to do easy onboarding, offboarding. So if you want to work inside of SKG to produce an ontology, you can create a new ontology here and put in whatever IRI code, put descriptions, and they'll bring you into the ontology editor that we'll look at in a second to work with your ontology and stuff like that. You can also upload something from Protege or from TopRate or from any other ontology engineering tool that you might already have like a prototype or concept for. You can upload that into here and start there with your concept, and you can start working with SMEs using that. Or you can create something with AI. And if you want to, say, produce something with, say, like, hey, I want to look at surveillance and reconnaissance for an unmanned area, unmanned. I guess we just do that. Operations for unmanned, and just put UAD. So if you don't know where to start in ontology engineering, most SMEs don't. like most subject matter experts, they know what they know in their domain of practice. They're engineers, they're scientists, or whatever. They generally know how to express knowledge in their semantics, in their words, but they don't know how to express it in BFO terms. So we have to kind of create a working space for them to work with ontology engineers to get an ontology produced that is BFO and CCO compliant, that can be used to produce something that can be reproduced over time using different data assets. So we have this little concept designer here that, once again, you can manually create it, you can create it from a template, or you can create it using AI to give you a baseline to say yes, no, maybe these elements inside these networks. And we can, using this concept designer, we can click on stuff, we like it, we don't like it, we can remove or add edges, add nodes, we can add property classes, add edges between these things. And once again, the AI is not going to at first be very good at this, because if you do a fresh installation, it has to learn from your stuff. So we have tried to align stuff to BFO CCO as much as possible, but ultimately when the concept designer, the SME, and the ontology engineer work together to get to a BFO compliant ontology, there's going to be a lot of massaging of stuff inside this little designer area. But once you have something here that you feel is consistent, rigorous with what the SME knows to be true about their domain of practice, then that's where the ontology engineer can really take over and really say, like, yes, this is kind of the baseline for the ontology we want to build. We have found as many CCO mid-level ontology stuff as possible that is compliant with BFO, and now we're ready to move on to doing some proper ontology engineering verification of this model here. So
what is the AI you're using? Are you using like GPT-4o or?
So when we have open internet, unclassed space, we do use ChatGPT, but we also have stuff based on Llama that can be used in isolated networks, so we can facilitate both of those. Tim, did you have any additional comments on the AI stuff that we do use, or I think those kind of the two baseline things.
That's right. Yeah, we support using some of the foundational models that are out there, like 4.0, but we also support using on-prem hardware resources if they are available, and then something like a Llama model as well. Yep.
But so once you have done that, so you can also save those as drafts, and people can collaborate on those drafts if they want as well. But at some point, the subject matter expert who works with unmanned systems and works with IoT, they'd be like, yes, I think we kind of have what I can express best as my understanding of what I do. Get more folks here. Express what they do and how they do it, and then the domain modeler, the person to help the SME do this process, the ontology engineer can kind of move forward to refine the model and to make sure that everything in here does align with some kind of BFO compliance that they, or has some kind of existence in pre-existing BFO models like CCO. So inside the space, this is where we can add properties, we can add annotations to each of these entities, in the AL RDF that's compliant with the DoD IC Foundry's kind of rules about how to build these ontologies consistent rigorously and how they get approved through the DoD IC Foundry. We want to make sure that anything that was produced inside the ontology editor here could be exported and verified via that process. So, but once again, it's hopefully a little bit better than Protege in terms of like building out ontologies and kind of publishing these things out there. It doesn't have as many buttons or tabs as Protege, but that's by design. We want to just have the essential tools needed to produce an ontology without having to worry about the implications of having to use that tool itself. But once again, if you want to use Protege, Top Rate, etc., we do allow import-export from those things. But all the tooling for doing ontology engineering here is built in. Creating, adding subclasses, adding the properties, the annotations, the rules, the axiomatics around these things. Everything that was in the ISO 21838 standards for top-level ontology, we try to have tooling built around each of those considerations for TLOs and BFO more specifically. So, and I think.
So, question: what kind of things are you leaving out? Like inverse of, or like, are you leaving out, like things like whether or not a class, has, say, I don't know, different general class axioms or,
Mhm.
you know, equivalencies, or are you leaving out is there things like that you're leaving out? Like if you have an object property, are you leaving out the fact that it can have a domain in the range? You're trying to make it more simplified.
Mhm. No, so the editor that we have right now is very rudimentary, and that was part of that was part of what I wanted to do with this presentation today, was to get feedback on what you all want to see in there. Because as of right now, it's the most basic of basic ontology editors. It's class, subclass. It's a lot of the RDF text augmentation from BFO and CCO. But as of right now, the big thing that we're working towards next was reasoners. But if there's more fundamental tools that you all need in here, you just let us know. We'll help integrate those features into this. But as of right now, a lot of those tools exist purely through the ontology engineer's application of the tool itself. But we can have those tools in there. You just let us know what you need, or what is the most fundamental aspects of like Protege or Top Rate that you use. We'll make
So
sure those
let's
things
say
get in
if I
here.
wanted to click on vehicle, right? Could
Mhm.
I get to its SCOS definition?
Not unless it's been populated here at the annotation, or if there's been something added to this record. So with our other, let's see, let's go back here a second to, I believe we imported this BFO from, so when we imported BFO here, the way that we've done our stuff is if you've built it in Protege or it's been built elsewhere, all those records and stuff like that that have been a part of that record in terms of BFO 2020 has been imported here to the platform itself. So
Is it being
inside,
imported as like a YAML file, or how is it being recognized? Is it in RDF?
yes, yeah, in
Okay.
RDF internal, yeah. So as of right now, like a lot of these things are just manually inputted into this thing. So as you see here in the annotations thing, like we can add the description, we can add the IRI references here, but then there's also the stuff that you would add here and edit, by yourself. It's like you can add a lot of stuff in here manually, but we'd like to automate as much of that as possible.
Yeah.
So, and like that, automation is the key here with all this ontology engineering portion of the platform. Is that
Yeah.
if it exists in BFO and CCO, we'd like to automate from that as much as possible. So
Yeah.
once again, any recommendations or advice is greatly appreciated. We'd love to build something that helps facilitate that
Seems like you guys
practice.
are in the Goldilocks conundrum, right? Where it's like
Mhm.
you don't want the porridge too hot, you don't want it too cold, you need the right temperature. So 10 years ago, we had the idea that every analyst can be an ontologist,
Mhm.
and that was what we tried to pitch to NGA. And then 10 years later, I'm like, I'm like embarrassed that I said that. I understand the purpose of behind that. I think the danger you possibly get into is that this just turns into an ontological label mapping
Mhm.
scenario, and that um, while the basic user doesn't understand that a class is more than its name, or even more than its SCOS definition, it's really its full shackle shape.
Mhm.
We were in a meeting like 2 years ago, and Mark Jensen, we were talking about deprecation.
Mhm.
And Mark mentioned that, well, if you really change some of the object property assertions, you probably have to deprecate. And I said, why? He said,
Mhm.
well, because a lot of times the object property assertions surrounding the class define the class greater than the definition does. So the total shape of a class has almost more of a definitive nature on the class than just what the human readable definition of it is. But if you don't even have the human readable definition available for the user, then they might get really confused, especially if we're trying to use information content entities, information bearing entities. And if we're just skipping over those, then we're losing a lot of ontological context. And I think that's the
Mhm.
danger with like a very, very, very basic user trying to build ontologies, is like
Mhm.
this idea that like they're just going to relate, like even our dev team, they just literally want to relate classes directly to like data sets. And I'm like, no, you can't do that. You got to create an instance, because you can't have object property assertions that aren't universal, between a data set and a class. And I'm really excited about this. I'm not coming off Like, I think this is awesome. This is one of the best things I've seen in a very long time. And I think that you're trying to tackle a space that's really difficult, especially linking it in with the IC. But I worry that if we make it too simple for a user, they're going to build a model that's incomplete or inaccurate because they're not given the holistic picture of what these things are. I don't know, John, am I speaking your language here? Or?
Yeah, I think you're right. I mean, like, you know, I'm excited about this too, for sure. But I think, you know, not like you're trying to address that Goldilocks issue, which is important. And but before I say any more, Matthew had a question, which is why I raised my hand. But I do not at all disagree with anything Jay has said. That's
Awesome.
I think he's on the money.
So the question that I had is, so I'm learning how to build ontologies, do them rigorously, BFO from the BFO end at the hub of BFO right here in Buffalo, right? And so you were like, hey, you can generate an ontology with AI, and then the ontology engineer can kind of come in and clean it up, you know what I mean, and kind of make it more rigorous. Then my thought was, and I use Protege right now, so that you know.
Mm-hmm.
My thought was, okay, but the verification step, when does that happen? Like, how do I know that it's, how can I verify it against BFO? Because what I would do in Protege is run a reasoner and see what kind of errors I got, and then kind of work backward from that and say, okay, well, here's what I did, da, 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 da. But with this one, I wasn't sure, like, does that happen within the platform itself? Is that something that happens maybe afterward? Is that something that has to be manually done by the engineer?
So yes, okay. So to answer these concerns sequentially, so in terms of backwards compatibility and deprecation, that the simplicity of this interface is the reason is part of the consideration for that, because one of the biggest problems with knowledge graph reproduction is that if there's a breakage in the canonical representation of what is governing the production of that knowledge graph, then you have a completely different knowledge representation at the end of the day. So we wanted to make sure that we didn't have tooling in here that would essentially contradict or stymie the ability to enforce changes in a mid-level ontology or an instantiation or an application of that ontology, and not have a way to call back to what was changed and how it was affected previous versions of that graph. In terms of verification, and that's actually a great question. And it's something that Tim and I have like game theoried to death. I think it's at most points. So the intent of the concept designer here, let me go back to the main interface here. Having this bend in ontologies is a bit of a misnomer. So the create with AI stuff is so that someone that is familiar enough with ontologies can help a person that has no idea what an ontology is express their idea in a mind map, essentially, to help them, because like I said, SMEs, a lot of people will not understand BFO, ontology engineering, none of that stuff. So you have to give someone the easy button to be like, okay, let me try and at least with nodes and edges express what I do as a subject matter expert in engineering, in science, in math, in economics, and allow me to express my knowledge in nodes and edges. Let's just get to that point first. And then the domain modeler that's helping them with that process, they can be like, okay, I'm going to go and put this into the drafts. And this draft right here, like, okay, I have an idea of what this maritime logistics or dogs or whatever we're testing out that day. Then the ontology engineer can go in like, hey, domain modeler, are you far enough along? Yes. So I think we have something we can start hacking apart and putting back together into a BFO compliant ontology. And once someone with BFO experience, with ontology experience, has looked at that and says like, yep, I see CCO stuff in here. I see other BFO compliant ontology stuff in here. I have all the new classes and subclasses that I've defined. Those all meet the metadata requirements in the OWL RDF and the DoDIC Foundry expectations for formatting all that stuff in here. Then they can publish that as an ontology. And at that point, that can then be used to produce a knowledge graph. But once it is published, you should have had an ontology engineer, someone familiar with that process, given it the omnis dominus, blessing it off, and saying, yeah, this thing can be used to produce knowledge graphs in a way that we don't have to worry about the common understanding of the entity models that go into those productions. So right now it's very manual, but it's at some point we are going to implement the user login and the user group policy to help govern. You have your SME modeler folks, you have your ontology engineering folks, you have your data engineering folks, and they all have different views of this dashboard. Right now, you're seeing the dev environment, the demo environment, because this is the top level admin access to it. But ideally, the ontology engineers, the modelers, the SMEs, the data engineers are going to see different things in this dashboard, and those things are going to be part of those verification steps to make sure that no knowledge graph is being produced without having some kind of BFO or TLO compliance there. Did that answer the questions on?
Yeah, no, that actually totally answered. So thank you.
Sweet. All right, now get into the fun part here.
Hey Joe,
So-
I have another question real fast. When
Yeah,
you guys are demoing, or when you guys are going in front of senior leaders and you want to pitch something, right? How do you approach BFO? Because the way that I approach BFO to seniors is I try to just approach it as, hey, this is a really, really high level. You're probably never going to have a user touch it. The only thing users would ever really touch on a BFO directly would be maybe disposition or function. So, and then everything else would just come down into like CCO land. But I could see an AI agent helping a new user build things like ICEs and IBEs into the system, like instantaneously. So then, because they don't really have to even know what those things are. I wanted to know what your thought on that was and how you approach that, because we try to approach it with like, hey, this is the way that like Aristotle thinks about like what is, and it's really theoretical, and users are never going to touch these up here.
No, that is a great question, and it is a situation in which I've been browbeaten many times for trying to go too deep too fast. And I'll let Tim speak to his experience with it. I guess the short answer would be like I let Jake talk, because Jake is way better at doing the simple expressions of these things than I'm not. So I want to get into the weeds of why it's important and why you should apply it. But I think with senior leaders specifically, they want to know what the value is. They want to know how it solves their problem. And they want to know exactly, they don't want to know all the bells and whistles, so to speak. They just want to know what the impact of it's going to be. And I try to stick to that as much as possible. So BFO generally comes up in the middle of the conversation in terms of like the governance and the rigor, the consistency. It's like you don't want to have to guess about what's coming out of your computer, because there can be a lot of shit that goes wrong. Oh, sorry, bad language. My apologies. Stuff that goes wrong at the end of the day. And you want to make sure you solve their considerations towards that, because they want to be able to trust their subordinates. They want to be able to trust their systems and make good decisions all the time in a way that's at a very high level. So I always bring up BFO in the middle of the conversation, and it's like a value add. It's like this big thing that no one knew about, but it's like, oh yeah, if you have time to look into it, you'll just see the immense impact that it does have on that end state of like, I don't have to second guess my systems, my people. I can rely on those. So I guess that would be my answer to when and how to bring up BFO, especially to non-technical senior leaders. Technical senior leaders, I can generally like get into the weeds a little bit, but with non-technical, I have to keep it to the most pragmatic aspect of top-level governed knowledge graphs, and I think that's kind of where I plant my flag, so to speak, in terms of how I weed it into conversations. All right. Any other questions, comments, concerns? Oh, Tim.
I was just going to say real quick, one, even for a non-technical leader, sometimes they are familiar with the problem of trying to use heterogeneous data sets together. And that can sometimes, or depending on the situation, oftentimes involve a need for entity resolution. And they might be aware of the high cost that can have, especially when data sets haven't had an ontology modeled for them. So sometimes when I express one of the values of using BFO, I'll touch on that as well.
Awesome. All right, so I guess I'm not sure what time we have. I think we're getting close on time here, but so once we have BFO confirmed, ontology engineers are happy, they're not going to murder anybody, then we can use that for a knowledge graph. So the last part of this is more where the data engineer and the other data scientists, analysts kind of take it out and use this thing. So once we have the ontology in there, we can take parts of that ontology to build knowledge graphs. You don't have to bring the entire hairball in there. You just need what you need to answer the questions for leadership. So we try to make that part of the engineering process as much as possible. So that's where the schemas come in. We take whatever part of the ontology that we produced to answer the leadership's questions. So it becomes, we concentrate on using the ontology engineering step also to help us really concentrate on what needs to be answered. So we're not pulling in the entire ocean. We just have a puddle there we can really effectively use to answer questions. So, and don't judge my stuff here. So this is an example of actually one of our customer success engineers with no BFO experience be able to walk through this process and produce something at the end of it. So it's exciting that different tiers of users can actually gradually learn BFO, CCO stuff and apply it inside the platform. So once we get to this point, we can go ahead and, if you know Gremlin, which is our graph traversal language, you can go ahead and just type Gremlin in here in the editor, but most people don't. So we have to be able to demonstrate and show like just simple language expressions like, inside of a schema, our unmanned systems have been classified as UXS. So let's just go ahead and say like, show me all, show me 10. Can we do 10? No, just show me UXS. There we go. Just do that. And we're going to go ahead and just generate a query from that. The system's going to go ahead and convert that into a gremlin using an LLM. It's going to convert that into an expression that we can actually use there. If you want to generate a summary from that, you can do that. We also have like text summarization as well in here. We can also traverse results as well if you want to traverse, and you can add what depth and edge limit you want to traverse to. So, but let's just go ahead and not do either though. Let's just run that and get some entities in this model here. So it'll pull like top 10 is what I think the general default is. So we can just pull 10 of these things in here. And if we want to start interrogating these things, we can start doing that. So if we want to, we can traverse them here and we can start looking at different aspects of these things. Oh, actually traverse, need to add some edges here. There we go. So we can start looking at things connected to this unmanned system, and we can start looking at different aspects of surveillance, reconnaissance, detections that occurred with that. So if we need to reference back to our schema to understand what the colors and things we're looking at are, we can go ahead and reference between the schema, the ontology, the graph output at the application instance level of the data to really dig into what we're seeing here and how we're seeing it. We can also turn on some mapping features as well if we want to concentrate on where these things exist in the real world. I'm not sure if it's going to resolve or not, but there we go. So we can have things pop up in the middle of the ocean here, and we can see exactly where this unmanned system is operating. We can also cluster a little bit if you want to like have a better idea of how many detections occurred inside that environment. A lot of utility here, but once again, keep in mind, this is all the effectiveness of this end state where we're doing queries, we're editing, we're looking at stuff, we have a graph. We can dig into the data here and look at all the data dimensions inside this thing for doing different analytic models. Oh, you know what? I skipped over the data engineering stuff. Sorry. Here, let's just generate a summary here and rerun that. Bam. Do that. Oh no. Oh no, I put way too much data in there. Anyhow, let me back up here a second and go into the code lab here. So I have this.
I have a question.
Yeah, go ahead.
Hi, sorry. With the way definitions work, how are you guys mapping different organizations' word to your application here? Because I would take an example. A facility is defined by different people differently. So how you guys handling those kind of problems?
So the automation steps between the ontology and the graph are largely done inside this notebook environment. And this is a clean environment. We just re-updated this instance, but usually there are any number of collections of notebooks to help you take all those entities that you established inside your ontology engineering phase and aligning data to those for the knowledge graph, and then selecting what parts of the ontology you want to use to produce the knowledge graph over time. So a lot of that stuff is still being done through this notebook environment, that's a whole of the presentation at this point. We'd have to set up another time to discuss all the stuff that goes on in this environment to produce this stuff right here. But the good news is that it can be done both inside the Jupyter Notebook environment and outside if you already have an pre-existing data engineering environment. So we can help you interoperate with your existing environment, or you can, if you don't have an environment yet, then the environment exists inside the platform. So.
And you're working purely with just signals from sensors that are under the water, right? You're not working with imagery data.
No, it's purely sensor stuff based in this, but we can incorporate imagery stuff. Anything that you can conceptualize and data we can engineer to get into this thing, we could easily integrate those things in this. We haven't had an imagery-based challenge yet, but
So
if you have one,
thing
we look forward to that. It'd be great.
One thing I want to let you know about imagery-based challenges, when you put your graph against a map, is that especially at some of the agencies, depending upon the system, there's orthogonal imagery and there's non-orthogonal imagery, and so it basically comes down to how the image is displayed against the ground surface, and so you need to know which one you're using, and so you might have like two that are interrelated, but one is orthogonal and non-orthogonal, so you have to work out that imbalance. So you might have to have different overlays of the earth so that each system can, because the problem is that say you have two garages right next to each other, right? And one's from an orthogonal and one's from a non-orthogonal, then you might think that like, oh, the street sweeper's in the same room as the ICBM, but they're really in different places. So just to let you know in the future, like with the sensor base that you're doing now, it's actually cleaner because you don't have to worry about that, you know.
Oh, of course. Yeah. I mean, it's all dots on the map at this point. Yeah. So when it comes to more and more abstract, you know, the lines, the multi-lines, multi-polygon, stuff like that, and then layering the imagery with that, yeah, it's a whole different ball game. Definitely doable, and something that like I said, we've put the fundamental tools for mapping and geospatial digital cartography stuff in here. But as of right now, most of our case studies, people just want to see instantiations of certain things on their maps. So that's pretty much where we're at right now with that. But once again, it's customer driven. So if you have a project that could be potentially used with that scenario, we'd be happy to talk about that for sure. Oh man, what else is there to talk about? I think that's pretty much.
Can I jump
Tim,
in
am
real
I
quick?
missing anything? Oh yeah, John. Yeah, please.
Yeah, so one, again, always impressive, pumped. I see a lot of visualizations of this sort, and I'm actually on the board of directors for a company that is creating a tool like for the open space that has this sort of like visualization built in. And I'm going to say to you what I say to them and everybody else that I see developing such things. And I say it in the form of a challenge because, but it's a persistent one that keeps coming up. I have no idea how I would use the visual. Like it's messy. I would ignore it in practice. I've worked with tools like this before, and I just ignore the graph, right? Like the visualization, because I don't know what I would do with it. And now I keep saying this to that group that I'm on the board for, and they're just like, it'll work out. We'll work out. I mean, it's really like a UI challenge, and I'm not sure how to solve it, and they're not either. It is a natural, what you've done is a natural way to present the information, but I have a hard time if I put myself in an Intel analyst's shoes, thinking that like I'd have to work myself into using. Does that make sense?
Yes. Yeah.
Visually, yeah.
Yeah,
So
we built one, John, where we spun it on the z-axis, so it was three-dimensional, and we basically built that because we went out to Pacific Northwest Labs, and they were doing stuff with basically not gene sequences but chemical sequences. And it was pretty wild because I could put on a virtual goggles and I could walk inside of like what fentanyl looks like, or what, you know, I don't know, some chemical that can kill you looks like, and you could spin it. And I've always thought that like our graphs are n-dimensional and you need to be able to spin them. You need to be able to get inside that way, because I agree, when it's 2D, it's really tough to look at. Yeah.
yeah, you know, the food on community, so like food ontology, it's easy, they're easy to Google. They have like a representation of this sort because they have to deal with a lot of like edges and nodes, and they wanted to give a three-dimensional perspective, so you could do something like walking through in the manner you described. It's in its infancy, but I think there's some promise in that direction. Although I want to turn it over to Ian because he's got his hand up. He might have something novel to say here.
Yeah.
Oh, there we go. There's Mike. Can you hear me?
Yep.
Okay. So one question, then a follow-up, depending on the answer. Does this platform, can you make any changes to data on the fly through this platform, or does that have to all be done externally, wherever the data is coming from?
Oof. Okay, there's a bunch of ways to add. I'll actually defer to Tim on that. I
Okay.
will. There's a bunch of ways
Sure.
to answer that question.
Yeah, no problem. We are on our roadmap is a plan to enable the user through the user interface here to modify data. And then second to that, you would use that code lab. So you would either perform updates to data that's in the graph, or add new data, delete, and perform those sort of CRUD operations, create, read, update, delete. And then we also support externally using the REST API and the graph endpoint to modify the graph and the ontologies, actually.
Okay, interesting. So I'm thinking of scenarios where, let's say you're making an ontology for a particular type of, you want to tackle some particular use case, but you don't have data that would demonstrate that use case, right, to a customer or something. I was considering, like, is there some way to, like, maybe write a, using LLMs, generate like dummy data essentially that you could test whether the ontology does what you want it to do in a certain context, even if you don't have the data to actually query over? Is that just something you would do externally maybe then?
Right now, we don't have the ability to generate right now in the platform through the UI, generate synthetic data for a given ontology, but definitely a feature we could look into.
Mm-hmm.
Yeah, and the ontologies would be great for informing, the restrictions and the dimensionality of the data that needs to be produced.
Mm-hmm. Cool, thank you.
Yeah, because that's something that we're trying to figure out how to do right now. Is like how can we create synthetic instance data to test things against, right? Right, John? Another question I have. So I've always thought a system, and I could give you my opinion. You can throw it away. I use TaxSlayer every year, right? And I use the wizard, right? And so I don't want to fill out all my taxes, but I do it myself, but I don't do it myself, right? Because there's something in the background. So it's going to ask me questions. It could say like, hey, what was your combined total income this year? What was your gross? And then it's going to fill out those other 9 boxes. So my question is, there are certain things that you want to do inside of an ontology or a knowledge graph that make it make sense, but we don't want users to understand this. So, a lot of these things are really repeatable models, right? Like, for example, if I have an ICE, I need to concretize it into an IBE, and then I need to have a data property that names it and all these other things. So in essence, could you say, like, what do you want to discuss? Oh, I want to discuss this. What do you want to call it? I want to call it this. And then you could ask it 3 or 4 questions, and in your system, it builds like, 4 nodes, 4 instances, but the user doesn't realize it did that, but it's doing it because you need those 4 things. Have you guys thought about doing stuff like that? Because the user is going to build you, if they don't have the knowledge to do those things, they're just going to build crap,
Mm-hmm.
and we don't want them to build crap. We want to build really good stuff. Have you guys thought about implementing at least some level of automation or AI to do some of these simple things? Like, for example, if you go to CCO's GitHub and you download their modeling, and they're old now, but and you say, okay, well, this is how I would model a date time situation, or this is how I would model, a location for an event or something. And then, you would just basically ask, the user could say, hey, I have a meeting at the White House, and then it automatically knows, okay, somewhere else in the model, I know where the coordinates are for this. So it might not even have to ask, for what the geo coordinates are. Have you guys thought about that level, or is that just way too far in the future right now?
Well, something that we have thought about that I think is similar to what you're talking about, is what we were calling a wizard approach, sort of like a question answer.
Yeah.
So Joe showed on the homepage that there's that generate with AI,
Mhm.
and maybe part of that workflow could include questions to the user, leveraging AI in its current form, meaning like LLMs,
Yeah.
um, to some extent, it can become contextually aware. So taking input from the user, it might also be able to sort of align the model to a certain domain of knowledge and then
Yeah.
know what other entities would be required. I think, but this also leads me to think about reusing existing ontologies for a given entity. And
Yeah.
that's where the CCO comes in and making sure that those are brought in when it is detected that that's what the user is trying to model.
Yeah, because I think most users, Tim, they're not going to be creating classes. They're going to be creating instances, right? So like they have a model where they have a Toyota pickup truck, right? And then the system has to be able to RDF type that to truck or Toyota truck or whatever is in your overall system. But they don't really have to even, like I've told this to Jeremy. I don't know if you've talked to Jeremy, but I told him that
Yeah.
most people don't need to even see BFO and CCO. They just really care about instance data, and it's our job necessarily to link them to the right things so they get the full
Right.
FOL and everything else for reasoning in the background. Would you guys agree with
Yes.
that?
100%. And I think that there's a lot of, this is something that I've been wanting more time to work on, a capability that we're currently calling SCTL, but taking what you can get out of some instance data. So even if it includes something like a schema or column headers, and then could be a great use case for an LLM, given its nature, which is that associating that with what is a standard class to represent those entities and detecting what those entities are, and then in the background, maybe transparent to the user, mapping it to something that's like in the CCO. It just detects it automatically based on maybe just giving it an overall domain in which this instance data is representative of classes, and then mapping that to something like something that's already modeled in CCO. So
Yeah,
yes, I agree with you, and I do think that could be a big next step with
yeah,
capabilities like this.
yeah. Because
And it's
keep it
basically
simple,
leading to a
stupid,
higher
right?
degree of automation.
Yeah,
Oh, I'm
and
sorry.
keep it simple, stupid. Like in the army, it was always
Yep.
keep it simple, stupid,
Yep.
right? And I think it's a really valuable thing to keep it simple, stupid, and to realize
Yep.
that most people only need the web app for Photoshop because they're only going to do 4 things. They don't need the 297 things. So when you have
Right.
pattern recognition, like, okay, let's figure out what are we recognizing? Okay, we have an act or a process, we have a material entity, we have a relationship between that. There's going to be patterns that like the system should be able to see. Oh, okay, yeah, it's making an assertion. The assertion is an ICE. The ICE needs to be concretized into an IBE to tell somebody about the assertion. It should be able to like auto generate that structure. And this user who might just be a all source intel analyst, they don't have to have that level of depth of knowledge to know that that's doing that. The system does that for them.
Yes. And then one of the grand ideas I would have is that the user can onboard data. The system, gets 90% correct the mapping to pre-existing ontologies like CCO. There's a user in the loop interface where they can correct it if need be, right? And then it learns from those corrections and aggregates that so that when a new set of data is onboarded, it can leverage past corrections and become smarter about how it's doing these mappings automatically to pre-existing ontologies. And then because you get that, you can also apply it to the instance data. So obviously, like a CSV is a simple example. You could more quickly detect when the data is bad, because when you've properly mapped it to the CCO, or you can apply these rules and know that, oh, this particular piece of instance data can't possibly represent a date time because it has invalid characters, or it has, those are simple rules to implement, but it also, to a point that was made earlier, there are certain properties that this class has to have, and because the instance data isn't there, this is not a valid representation of an instance of this class. And so you could accomplish more like that as well.
John, you have a question?
Yeah, I have something coming out of my experience, and I could see a way in which this environment might be beneficial, although I just want to throw this out there as like a potential use case to think about in the future, as maybe an avenue forward that would bring as I understand it, quite a bit of value to the community. And I could see the lines in which it might help through this environment. But the use case is this. So and it's probably quite familiar. Not developers using the stuff that we build don't always need all the edges and nodes that we use, right? Like they don't. In fact, they might get quite frightened by the full representation. The more edges, the more nodes, the more they have to do, right? And so, in my experience, what a way around this, one, we work with developers, of course, as ontologists, and understand what they need to do from, say, a general functional requirement that we're all trying to satisfy. What do they need out of that? What do we need out of that? And I don't have to give them the full ontology picture. But what I do need to do is cut what they need from that whole cloth and give them the minimal edges and nodes that they need for like their UI or for their NLP application or whatnot. And so, as I understand it, is often a bit of a manual process. One, getting to that point where we are accurately identifying exactly what they need. Two, it's, as I understand, even now, like very much a manual process of cutting out the pieces and showing, like having demonstrable proof or like an automated way to demonstrate that this is in fact cut from the whole cloth. You can go back to the broader pattern if you need to. And of course there's always the issue of like versioning if they change, as you have this one pattern over the broader pattern and the smaller pattern over here. So what I'm highlighting here, like these like three issues that, as I understand, have been like stumbling blocks for continued like rapid development. Again, just to reiterate, one is that the manual interaction between ontologists and the developers to identify under a guidance of a given functional requirement what minimal structure is needed for the developers out of the whole cloth that is the ontology. Two, there's that, how do you like demonstrating how you go from the bigger cloth, that bigger ontological representation, to that smaller pattern and show that they are in fact aligned and they maintain alignment. And then three, what happens when you version, one or the other or both. And that happens, right? The functional, your sponsor might say, take a detour, but not a full detour, slight deviation. Now you have to change the pattern. It happens all the time. But yeah, I don't expect you guys to solve all these problems, but I could see lines in which this might be helpful to address some of that or mitigate some of that real burden that I see.
Yeah. And John, to caveat off you, it's sort of like how we have RDFS label, which is the ontologist preferred label, then we have SCOS pref label, because we're never going to call it active swimming. We're going to call it swimming. We're not going to call, like, some of our RDFS labels are ridiculous, right? And we know they're ridiculous and ontologists use them, but we would never have a user use them. And it's sort of like having SCOS preferred connections for a basic user to have, and then the other connections, like I've told Jeremy this. I said just have the instances in the front, and if you want to click a button that shows you all the classes you're connecting to, you can do that, but they don't care about that. And it'll be the same thing. We're like maybe we just have to have a relationship between the car and the truck, but we don't have to have in the SCOS pref view or the user pref view all of the relationships required so that AI can do its job and ML can do its job in the background, because it's working on all these other object property assertions that the users can be like, whoa, this is too much. It's overwhelming me. I don't need this. I just need to know that the car is driving down the road. I don't need to know that the road, which is I-95, is segmented into 100,000 different segments, and I'm connecting all the segments of the road in my knowledge graph, right? It's the same thing like when we show people our knowledge graph, we tell them, if we have a senior, we say our knowledge graph. We don't tell them, hey, it's actually 27 knowledge graphs, that we're combining. We don't go into that rigor. Yeah.
We certainly don't point them to the whole graph, like the whole structure. And that's really the through line here. Like whether it's an annotation property like a label or an axiom that links one part of a hierarchy to another, like from a developer standpoint, it's very easy to see these are edges and nodes. And like, what are the minimal number of edges and nodes that I need to get my application like satisfying its functional requirements? So I think there's that through line.
Yeah, that's a nice segue to the last thing I was going to show, which is our chats feature. So it's one of those things where, at the end of the day, when it's a non-technical decision leader, decision maker, leader, we want them to just be able to go in here and be like, oh yeah, just ask some questions about certain things about the graph, and just hit run. So don't actually see the graph, don't see anything there. They can just ask the knowledge graph question. The LLM will give it a summarization. Like I said, it'll give you this, give you the data. They can export the data from here if they want to. But then all they need to do is read this little description down here and be like, oh, okay, this is just a summary of what I've been asking a question about. So we're trying to get this tightened in and better as well. But the idea is to, once again, going from our history back in 2019 to now, the event-driven decision-making stuff, allowing someone that has no idea about BFO, knowledge graphs, data engineering, the subject matter experts that go into making this stuff work and work well, they just want to be able to ask questions, get answers back, and then if they need additional context, they know who to go and talk to. So we've tried to make the platform a good workflow to go from raw data, questions, subject matter expertise to a simple interface that allows a decision maker to go, I have questions, I need answers, and give them a place to start with that process. And that way you don't have to worry about the hairball. They can just focus in on like, I know there's something in here. Let me go and ask questions. Let me get the people around the table to get their stuff done. So, but if they want to get more technical, they can dig down certainly into the whole platform and see exactly what they're seeing here in the chat and every other aspect of this platform itself. So they want to go in here to the knowledge graph and dig more, they can. If you want to dig into the ontology, they can go back here, dig into the ontologies. Completely up to them how deep they want to go down the rabbit hole, so to speak.
So Joe, I have another question. So you said you could bring in a Protege file, right? Which essentially is just the turtle file that you worked in Protege.
Yep.
My question is this though. One of the problems that we had 10 years ago going from RDF graphs to property graphs, because that was back in the rage of, oh, we have a property graph, and we said, well, you can bring your full property graph into our RDF graph, you're not going to lose anything. But if you try to take our RDF graph into your property graph, you're going to lose 80% of it. So my question is, with your setup, because you don't have everything from Protege or from basically OWL 2.0 in here, if I bring in a file that I worked in Protege and I bring it in here, what happens to all the other stuff?
Now that's I love you for asking that question. I love everybody on this call. This is great.
No, you don't. You hate me right now.
No. Tim and I have had this argument several times. So yes, yeah. So you can bring it in. It does cut off some of the stuff. I'll let Tim talk to more about this, but it's a persistent challenge. We're trying to capture as much stuff on import as possible. But yeah, Tim, I'll let you because I have my own opinions on it. But yeah.
Well, yeah. So as far as RDF that represents the ontology itself, we keep it in RDF format for the ontologies.
Okay.
So that. I think that might just answer the question. Our instance data we currently store in a labeled property graph.
Okay.
Yep.
So if I worked the file with Ian in class, right? And we worked it in Protege, and then I saved it as a turtle file or as an RDF XML file, and I brought it into your system and I worked on it. Okay, and then I saved it as an RDF XML file or saved it as a turtle file, and I brought it back. Would the things that you don't utilize, would they just be someplace dormant that they're not being touched? And would the only thing being edited would be the stuff that your interface can interact with? And I'm not going to lose any of my data? Or do you strip it and it's gone? And then when I save it, it's just going to be a stripped down version of my original file.
Our goal with the platform would be to retain everything that was there and only modify what the platform supported, for which the platform supported modifications. So that would be the goal.
Okay. Because if you do want to have a senior ontologist in the loop, right, and be somebody who blesses off on something, they probably are either going to want to open it up just in VS Code, right, and just read it like John, who's a psycho, does. I'm starting to become a psycho like that. Not there yet. I'm there a little bit. Or they're going to want to open it in something like Protege, right? I tend to like to open it in both because then I can see the taxonomical structure really easily, and then I can just read the code. But if unfortunately you give a file to a user, the user modifies it, and then you get it back, and then now I need to maybe go back and do an import back into my original, like, you just want to probably make it as user friendly for those groups of people as possible and not have data get lost. Yeah.
No, absolutely. We would not want to lose anything that might have been added by Protege I know Protege supports plugins. We've talked about having feature parity with Protege, as far as the editing capabilities and what it can edit. So that's an ongoing discussion as well. But we definitely would not want to lose anything, because I know that a lot of tedious work can go into making sure all that's there and things are properly represented.
Have
Yeah,
you
and
thought
we-
about using like I don't know if GPT-4 has the plugin yet for Canvas. Canvas is pretty cool. Have you guys thought about using that?
No, we can add to the list though. But as right now, like to Tim's point, like we just want to make sure that in terms of just the raw data, that we have provenance lineage back to the raw import, whether that's the ontology, the data assets. Right now we do have a data lakehouse, essentially like base layer for a lot of our like the initial data engineering database, base stuff. So all your raw data just kind of goes there. So if you have S3 parity, you can also go there as well. But all that raw data, all the raw ontology files, everything goes into that store. So, or should be in that store. So if you wanted to go as far as to digging into the raw data and raw ontology imports like that, that would all be there. And it can be accessible through VS Code, through the API layer, through the Jupyter Lab environment that we have embedded in the platform. There's a lot of ways to access that data once you get it in there.
Okay.
You get it processed into the graph. But to John's point, it's that winnowing down into exactly the tiniest effective hairball possible, so that no one has to deal with the implications of thousands of entities inside of the broader mid-level ontology collection that you have inside of the platform itself. So the efficacy of someone using the platform comes down to our efficacy of winnowing down their workflows into the most efficient, shortest steps possible. The whole Dijkstra challenge of getting them from A to B in the most effective way possible. And that's very much our goal now. So
Okay. So they're always going to have the full corpus available to them. They're always going to have the full corpus. They're not just working off a slim. They're always having the full corpus available. That's cool. Yeah.
Yeah. I'm gonna have to, so we're a little over. But this is fantastic. I just want to say a couple of closing words, if that's okay.
Yeah.
One up front, you just quoted Dijkstra, so I'm already way on board. How often does that happen? I love it. So, but more on a more serious note. So, I'm often talking about the big picture, the vision, like for the community that I'm seeing, the various, like the big jigsaw puzzle that we're trying to solve. And like I've seen a lot of groups working on like representation, tooling, like creating slims, automating parts of the process. This is one of the only teams that I've seen that's taking the governance portion seriously and trying to integrate this stuff from that perspective, which I think is just absolutely key. I'm always impressed. I am impressed now. I'm very pleased with what I'm seeing. And I'm also incredibly pleased with the fact that the team is so open to like trying to figure this out, which is the right attitude, because we are kind of creating the tooling, the strategies as we go. I wish it wasn't like that, but it is. It's also a bit invigorating, so I'm kind of excited about it on an intellectual level. I'm just deeply impressed and very thankful and grateful that you took the time to present this. And I am happy to spread this word. It's great work, guys. Great work. We should give them a round of applause.
Oh yeah, it was great.
Thank you.